In this video, I will show you how to calculate the average rate of change and the average value of a given function on a given interval. The average rate of change of f of x will be calculated using this formula. You can see it's just an old school slope. We're doing y minus y over x minus x. Whereas the average value is the integral divided by the interval. Problem number 1. On the interval from 0 to 4, the average rate of change is going to be the old school slope f at 4 minus f at 0 over 4 minus 0. Again, this is just y minus y over x minus x. So we need to calculate f at 4. Substituting 4 for x, we have 6 times 4 squared minus 6 times 0 squared over 4 minus 0. Well, 4 squared is 16, so we're going to have 16. Well, let me write 6 times 16. And then 0 squared is 0, so the second term is really gone. So I have 6 times 16 over 4. Let me make a new column. 4 goes into 16 4 times. So I'm going to have 6 times 4, which is 24. So that is the average rate of change. On the other hand, the average value from 0 to 4 is going to be the integral divided by the interval. So the integral from 0 to 4 of f of x dx, all right, divided by the interval 4 minus 0. For the integral of 6x squared, I'm going to use the power rule of integration. So I'm bringing down my x, I'm increasing the power by 1. That's x to the third power. I need to divide by the new power. 6 divided by 3 is 2. So this is the antiderivative of 6x squared. But we must evaluate on the definite interval from 0 to 4. So the way you evaluate this definite integral is you find the value at 4 and you subtract the value at 0. So I'm going to do 2 times 4 to the third power minus 2 times 0 to the third power over 4 minus 0. Let's see, 4 to the third power is 64, so I have 2 times 64. 0 to the third power is 0 times 2 is 0, so the second term is gone. In the denominator, 4 minus 0 is just 4. I am going to reduce 2 over 4, so I will have a 2 in the denominator. So now I have 64 divided by 2, which is 32. So this is the average value. Problem number 2. Let's find the average rate of change on the interval from pi to 2 pi. Here's the setup for the average rate of change, like an old school slope going y minus y over x minus x. But the function f of x is sine of x. So we will get the sine of 2 pi minus the sine of pi divided by 2 pi minus pi. The sine of 2 pi, which is the same as the sine of 0, is 0. And the sine of pi is also 0. 2 pi minus pi is just pi. So that's going to give us 0 over pi, which is equal to 0. So that is the average rate of change. Here is the setup for average value. It's the integral divided by the interval. f of x is sine x. So now we have this. The antiderivative of sine x is negative cosine. So I'm going to have negative cosine of x in the numerator, but I will need to evaluate this from pi to 2 pi. I need to use my limits of integration. And all of this will be over 2 pi minus pi. You evaluate a definite integral by finding the value at 2 pi minus the value at pi. So I will have negative cosine 2 pi minus negative cosine pi. Notice the double negative here. And meanwhile, I still have 2 pi minus pi. Don't worry, I will simplify that on the next step. The cosine of 2 pi is the same as the cosine of 0, and that is 1. But don't forget the negative sign in front. So we actually have negative 1. Minus a negative is addition. And then the cosine of pi is negative 1. So we have negative 1 plus negative 1 over, and 2 pi minus pi is pi. So this gives us negative 2 over pi. So this is the average value. Number 3, let's set up the average rate of change for the interval from negative 1 to positive 1. So the average rate of change is really just the change in y divided by the change in x. So I am going to evaluate e to the 2x, so this will be e to the 2 times 1 minus e to the 2 times negative 1. Minus a negative is addition, so I think I'll go ahead and put 1 plus 1 here for fun. E to the 2 times 1, that's just e squared. And then here, e to the 2 times negative 1 will be e to the negative 2 power. Meanwhile, 1 plus 1 is 2. This is a perfectly acceptable answer for a free response question. However, if you are given a multiple choice question, the answer probably won't look like this. They usually rewrite it so that there are no negative exponents. The way you can neutralize a negative exponent is by multiplying it by the same expression with a positive exponent. So if I multiply e to the negative 2 times e to the 2, these cancel each other out and make 1. The only way I can do that legally is by doing the same thing in the numerator and the denominator. And yes, I'm doing the distributive property right here. So on my next step, I would get e to the 4th power, right? That's e squared times e squared. As I mentioned a moment ago, e to the negative 2 power times e squared is going to cancel out and make 1. Meanwhile, in the denominator, we have 2e squared. So this is the version of the answer that you would likely see on a multiple choice question. Let's set up the average value of f of x on the interval from negative 1 to 1. Average value is integral divided by interval. So the integral from negative 1 to positive 1 of f of x dx, all right, that's the integral divided by the interval, which will be 1 minus negative 1. But f of x is e to the 2x power. So this will become the integral from negative 1 to positive 1 of e to the 2x dx divided by, and I think I'll go ahead and put 1 plus 1 for now. So we need to integrate e to the 2x. I am using a mental u substitution to find this antiderivative. In my mind, I'm thinking, let's let u equal 2x, which means that u prime will equal 2. When u prime is a constant, the only thing that's going to change is I'm going to end up dividing by this constant whenever I evaluate the integral. So I'm going to go ahead and say that the integral of e to the u is still e to the u. So when I integrate, I am still going to have e to the u. However, like I said, I'm going to wind up dividing by u prime. So I will have this 1/2 out in the front. This is a definite integral, so I'm going to have to evaluate using my limits of integration from -1 to +1. And I'll leave it as 1 plus 1 for one more step. When you evaluate a definite integral, you find the value at the upper limit minus the value at the lower limit. So I need to do 1/2 e to the 2 times 1 minus 1/2 e to the 2 times -1. The upper limit, value at the upper limit minus the value at the lower limit. Okay, and over 1 plus 1. Simplifying a tiny bit gives me this. Let's neutralize the e to the -2 power by multiplying by e squared over e squared. If I multiply e to the -2 power times e to the 2 power, they cancel out and give me a 1. Now I do need to do the distributive property. But now that I think about it, how about if I multiply by 2e squared over 2e squared? I don't like having a fraction inside of a fraction. So I would like to cancel out the fraction as well. So if I do 2 times 1/2, that's going to be 1. So those cancel each other out. E squared times e squared is e to the 4th power. If I do 2 times 1/2, that's 1, so the 1/2 is gone. And then e squared times e to the -2 power is 1. Look how simple this is. This is much better. 2 times 2e squared will be 4e squared. This is the answer that you would probably find on a multiple choice question. But to be clear, for a free response question, you could have left your answer like this. Number 4, let's set up the average rate of change. That's the old school slope on the interval from 1 to 4. So I'm going to do f at 4 minus f at 1, divided by 4 minus 1. F is this sort of complicated function, so this is going to take up a little bit of space. But here I go. F at 4 would be 9 over 2 times 4 plus 1. So that's f at 4 minus f at 1 would be 9 over 2 times 1 plus 1. And this is all over 4 minus 1. 2 times 4 is 8, plus 1 is 9. So this is 9 over 9, which is 1. And this is 2 plus 1, which is 3. And then 9 divided by 3 is 3. So I have 1 minus 3 over 4 minus 1. But that is -2 over 3. So this is the average rate of change. The average value is the integral divided by the interval. The integral from 1 to 4 of f of x dx divided by the interval 4 minus 1. This is how you find average value. Substituting 9 over 2x plus 1 for f of x gives us this. We can take the numerator of 9, this constant, and pull it out in front of the integral. So then we will have 9 times the integral from 1 to 4 of 1 over 2x plus 1. Of course, 4 minus 1 is 3. So we can actually go ahead and simplify this while we're at it. 9 divided by 3, of course, is 3. So on my next little rewrite, I will have 3 times the integral from 1 to 4 of 1 over 2x plus 1. Whoops, I forgot the dx, y'all. Whoopsie. I am about to do some mental u substitution. In my mind, I'm thinking, let's let u equal 2x plus 1. I'm not ever going to actually write the u in here, but this is what I'm thinking. And then u prime will equal 2. When u prime is a constant, I always do mental u substitution. I know that when I integrate, I'm going to wind up dividing by 2. So in the end, I'm going to have a 2 right here underneath this 3. Anyway, think of this as 1 over u. We memorized a long time ago that the integral of 1 over u du is equal to the natural log of u. Well, plus c. So the integral of 1 over u is going to be the natural log of u. Instead of putting plus c, I'm going to use my limits of integration from 1 to 4. And like I said, the only thing I have to watch out for is the u prime. I always wind up dividing by the u prime. So I do have to put this 2 in the denominator and make it a 3/2. It is time to use the limits of integration. I need to find the value at 4 minus the value at 1. So this will be 3/2 times the natural log of 2 times 4 plus 1 minus 3/2 natural log of 2 times 1 plus 1. This quickly becomes 3/2 times natural log 9 minus 3/2 times natural log of 3. I need to make one small correction real quick. My little rule here, the integral of 1 over u du is the natural log of the absolute value of u, which means that back here, when I had my 2x plus 1, I should have written the absolute value of 2x plus 1. Okay, so I'm still evaluating from 1 to 4. Let me just clean this up a little bit. I think I can just stick it right on here. 1 to 4. All right, the rest of it doesn't change. Notice the common factor of 3/2. I'm going to bring that out in the front. So I have 3/2 times natural log 9 minus natural log 3. By the way, if this was a free response question, either of these would have been fine for the final answer. I'm going to keep going to prepare for a possible multiple choice question. So here's something special, property of logarithms. If you have the natural log of something minus the natural log of something, you can combine these into a single log. It's called the quotient rule of natural logs. So natural log of 9 minus natural log of 3 is the same thing as the natural log of 9 divided by 3. I still have the 3/2 in the front. Of course, 9 divided by 3 is 3, so this would be 3/2 times the natural log of 3. This is the version of the answer that you would find on a multiple choice question, so you better know how to get it. Problem number 5, last one. Let's set up the average rate of change on the interval from 0 to 1/2. Remember, this is the old school slope. We're just doing y minus y over x minus x. So here is the setup. Next, I need to do f at 1/2. So I'm going to write this whole thing, but I'm going to plug in 1/2 for x. So I'm going to end up with 1 over the square root of 1 minus 1/2 squared. So this whole expression is f at 1/2. And then I have minus f at 0. So that's going to be 1 over the square root of 1 minus 0 squared. And then this is all over 1/2 minus 0. On my next step, 1/2 squared is 1/4. So I have this. Obviously, 0 squared is 0, so I'm just left with this. There used to be a 1 right here, y'all. I'm replacing the 1 with a 4 minus 4 to help you see that I'm going to get 3/4 right now. So now I have this. The square root of 3/4 is the same thing as the square root of 3 divided by 2. I'm just taking the square root of the numerator and the denominator separately, and the square root of 4 is 2. So I have this, still have this -1 floating around out here, and the 1/2. When you divide by a fraction, you multiply by the reciprocal. So I'm going to get 2 over radical 3. Instead of writing a 1, I'm going to write radical 3 over radical 3, so I have like denominators. And then I have this 1/2. Combining these, I have 2 minus radical 3 over radical 3. And I was about to write divided by 1/2, but let's go ahead and say when you divide by a fraction, you multiply by the reciprocal. So let's go ahead and multiply by 2. So I'm going to multiply by 2 like this. Any of these would be acceptable answers on a free response question. So everything I do now is trying to get different versions that I might find on a multiple choice question. So this might be an answer that I would see, or they might distribute that guy, distribute the 2. So I might see 4 minus 2 radical 3 over radical 3. Can we cancel out these radical 3's? That feels tempting. Nope, that would be some bad algebra. You cannot cancel out things when you have terms that are connected by addition or subtraction like this. One more time, let's set up the average value. The integral divided by the interval. So we're going to do the integral from 0 to 1/2 of f of x divided by the interval 1/2 minus 0. Substituting 1 divided by the square root of 1 minus x squared for f of x, and we have this. This looks very familiar. This integral is a perfect match for the arcsine rule, where the u value is just x and the a value is 1. So the integral of 1 over the square root of 1 minus x squared will be arcsine u over a. So that's just going to be x over 1, which is just x. Instead of putting plus c, I am going to evaluate using my limits of integration, which go from 0 to 1/2. And don't think I forgot about this 1/2 in the denominator. Dividing by a fraction is the same as multiplying by the reciprocal, so this will become a 2 out in the front. To evaluate a definite integral, you need to find the value at the upper limit minus the value at the lower limit. So this will be 2 arcsine 1/2 minus 2 arcsine 0. To evaluate arcsine 1/2, ask yourself the sine of what angle is equal to 1/2. The first thing that pops into your mind should be pi over 6. There are other answers that would give us 1/2, but inverse sine has the following restrictions. It only exists between negative pi over 2 and positive pi over 2. So the only possible answer is pi over 6. What about arcsine 0? Ask yourself the sine of what angle is equal to 0. The angles that pop into my head are 0 or pi, but which one of those fall within the restricted values of arcsine? Only 0, not pi. So the arcsine of 0 is 0. 2 times 0 is 0, so this term is gone. And we can reduce this a bit. 2 goes into 6 3 times, so we end up with pi over 3. And this is the average value